3, 5, 7, 9. Just 9. He even said I'll give 1% credit for just showing up. Okay. Repeat this for people show up. Okay, please come closer. We're going to do a demo. Just waiting for more people to join so that I don't have to repeat this. 6, 7, 10, 11, 7 more. Yeah.
Have they just given like no response?
We'll talk about it separately. We don't want to speak in front of you.
I'd like just yes or no, have they given any response?
No. Okay, so for the course project, we set aside 20%. I'm not turning this project into another writing exercise. I know in many courses you're doing projects and preparing reports. We want to keep this more focused on learning and somewhat fun for you to actually do. Okay, so in module 5, we looked at control volume analysis. You can think of this funnel where let's say we fill this with soap, which is a very steady flowing viscous liquid, which is easy to work with for this experiment. What we want to understand is, let's say we think of two types of experiments. One in which you keep the funnel full at all times by keep replenishing soap. Okay. And then let's say you fill this up entirely and then you block the bottom, and then we start the experiment where the liquid starts flowing out. Obviously, the liquid level would come down. Okay. So the first experiment we can think of is, hello, Dr. Hochstein. So I know you all know Dr. Hochstein. He's the one who wrote the book, literally. So thank you. So I'll just start over. What we want to do through this project is to do an experiment that does a measurement with instruments that you can find at home, mostly like a cell phone, to record a video. And from the video, we want to figure out something. Okay. So one of the ideas I have is, let's say you fill this to the top with soap solution, which is a nice viscous, easy liquid to work with, and we keep it closed. And at time 0, you open the bottom, the liquid starts discharging. Now, if you don't replenish, obviously the liquid height will go down. One measurement would be to use a video camera to track the liquid height as a function of time. And from your frames, you can plot h height from this datum to here, h as a function of time. So it will start at whatever the length of the funnel is, and it will fall over time. And you want to report height, instantaneous height as a function of time. So that is a measurement we want to do. Right now, let's not worry about how to calculate it if we are just going to measure it. So that is one observable, the height of the liquid level as it falls over time. The other observable is there is flow rate coming out of the tube here. Now, what is flow rate? We learned flow rate is cross section times area. Now, if you track the liquid coming out, it's going to have a width, and the cross section is circular. You will find that even though this cross section is circular, the cross section of the flow will be smaller than the cross section of the funnel that I'm going to show a demo right now. So you're going to see that the cross section of the flow coming out is slightly smaller than the cross section of the funnel here. So using your, again, camera, you want to figure out what the width of the flow is. And from some idea of how fast the flow is moving from the images, you want to be able to say what the flow rate coming out is. Okay, so again a measurement. Okay, so let's do a demo here. I don't want to keep talking. So here is where I need 3 volunteers to take videos from different angles so that you can later see what your experiment would look like. Okay, so step 1, I'm filling this with soap. Okay, as many angles as possible. So feel free, if you have your camera phone with you, just take a video. This soap is not particularly useful because it's like almost like jelly. It's a very old soap. I have some fresh soap here that I brought from home, which if we need it, we can use. So here is I've filled it out to the brim. Okay, so this is initial condition T0. Do you want to come over here, Dr. Augustine? If it's hard service. Okay, so here is T0. The height is up to the brim. Okay, now we want to start the experiment. So you have a, let's say, a 3-person team. One of you is going to operate the camera, coordinate the clicker, and make sure that you record this from time 0. Okay, so you open the thing and you start the liquids flowing out. So if one camera is focused on the height of the liquid in the funnel, you can get a measurement of h of t. And if the other camera is focused on the fluid coming out, I told you that the fluid cross section will be smaller than the nozzles or the smaller than the tubes, which you can see here. So from the width of the cross section and the speed and the linear speed with which the liquid is falling, you have to figure out flow rate. Cross section multiplied by velocity will give you flow rate. Now, this liquid looks clear, so you have to figure out how will you image it, and from that, how will you figure out the velocity. You might have to add some color, you might have to add some little sand particles or something to mark it so that you can measure how fast the liquid is falling. That makes sense? All the time we always get accused of giving you boring, unpractical exercises. So I want you to try something and get your hands soapy. How about that? Okay. So I'll do the demo again. Fill this with liquid. Okay, that's not quite to the top. So one measurement is focused on the height, or one camera is focused on the height. One camera should be focused on the liquid discharge. Okay. So I'm going to do that again. So you can see here various things happen. Sometimes you can have such dripping or oscillations that depends on the liquid. So I got this soft soap. This is brand new. You may not see this phenomenon with brand new heavy viscous liquid, but this old soap is more or less like jelly now. It's starting to have non-Newtonian behavior. So you want to capture all the oscillations, all the time-dependent behavior or steady behavior. An experiment is about observing. It's not about having preconceived notions of what you should observe, but you should try to report what you measure and be scientific about it. Got it? You're not going after any particular goal. You don't have to solve any problem. You're setting up a measurement and reporting numbers accurately. Okay. So questions now are, I told you need to measure the width of the liquid coming out, or you need to measure the height of the liquid at any given instant. How do you do that? You can have a camera. You need to calibrate the camera. You need to put a ruler. You need to understand if in the frame the liquid drops by a certain distance, how much is that distance in real units? And you need to be able to report millimeter, h in millimeters, and this flow velocity in millimeter per second or whatever, and a flow rate in millimeter cube per second or centimeter cube per second. So it's easy to describe the problem, but when you get down to actually recording a video and convert that video into a length or a velocity, you will learn new things about how calibration works and how to actually pull off a measurement, which is much more complicated than solving like for total derivative using the given fabricated or doctored problems. So that's the hope of this whole project. Okay. So this is one type of problem. So I'm going to divide this class into two groups. One group is going to do an experiment where, like what I demonstrated so far, you fill the funnel to the top, shut this with a coin or something, open the coin, let the liquid discharge out, track the height of the liquid as a function of time, and track the outflow, velocity, and flow rate. This is a unsteady problem. Why? Because the problem eventually, the liquid eventually goes to zero, the velocity eventually goes to zero, the height eventually comes down to zero. So it has a start and an end to the experiment. The other experiment, that is one group, one set of 9 students will do the unsteady experiment. The other 9 students are going to do a different experiment wherein you have a 3-person crew, right? One of you is going to just be making sure the liquid level is always near the top. So we solve problems where we have a huge tank and punch a hole at the bottom, and we assume that the top level of the tank is nearly steady and solve for flow rate or velocity. We are going to simulate that by having, let's say, one second. I have to open some new source. Do you mind getting your hands soapy? Can you hold this funnel? Yeah, just hold it. Okay, so the other experiment is you start similarly with the liquid level at the top, but somebody has to maintain the liquid level always full. That as liquid keeps flowing out, the level will drop, but you have to act like a human controller, keep dropping more soap to keep the liquid nearly at the same height. You have to maintain the same height. And then the camera image will capture. Thank you. So actually, can you come over here now that you have your hands soapy? Can I get more work done from you? So while the liquid is flowing, you are going to squirt more soap into this and keep the top level constant. Okay. Oops. All right. So you see the liquid is flowing, but I mean, he has to act even faster to put more liquid in so that the flow rate is approximately constant. And as the old soap washes out, the new soap is nice and viscous. I told you it's Newtonian. The other soap is like jelly, non-Newtonian. So you can see that if the liquid level is maintained steady, there are still some unsteady effects or some oscillations in the liquid cross section. It's more or less steady, but there are some unsteady effects. We can think a lot about what happens only if we are able to collect data about what happens. It's easy to speak hypothetically like we do when we teach, but this sort of an experiment gives you a first-hand experience in observing what happens when you discharge a liquid through a funnel, and then you can go on trying to interpret that and build a model using control volume analysis or whatever. Okay, so thank you. We're good here. Let's settle down. Thank you. So we have a class of 18. I want to segregate you into first 2 groupings. One will do the unsteady experiment. The other 9 will do the steady experiment. We can talk about who wants to be where. And within that 9 groups, we are going to split you into 3 groups of 3 students each. And each group will do the same experiment. It's like I'm asking 3 groups to do the same thing so that we'll have some comparison of how different people execute the same idea. It's an idea that I'm giving you. You may do it differently from you. So we want to see that variability, to see how you pull off things, what sort of calibration that you can come up with. Ultimately, if you present me a video, that isn't enough. What I want is a graph, height versus time, flow rate versus time for the unsteady experiment, And for the steady experiment, flow rate versus time or flow velocity versus time over the course of the experiment. That makes sense. I'll write some of this down, but you guys have been very quiet. Any thoughts, any questions first, just to get some discussion going? Yes.
So when we're doing the experiment, do you want somebody to hold the funnel or do you want?
You can have a stand to do that. Whatever, see, you have only 3 people, 6 hands. So try to, I did this because I didn't have time to set up everything. But if I'm doing this, I would put this in a stand.
Yeah.
I would even, if you can find a way to have like a bottle with a knob that you can turn and set it at a steady rate so that it will keep replenishing your flow. Automate whatever you can. You can keep your camera in a stand so that you don't have to stand and hold there. If you can program it or time it to start and stop whenever you want it, that will be fine. The core concepts in this thing are making sure that the length you measure from the camera is accurate. And how you do that, any ideas how one would measure or take a video and take the distances in the video to length?
You can label measurements on the funnel. So you can just already have it measured, so you can see it directly in the.
First of all, funnel is not planar. Second, it's not only about labeling, it's about the distance and at the focus and magnification, you need to have a certain conversion factor that takes pixel length to real length, pixel to centimeter or pixel to millimeter. So just to give you an analogy, do you know what's a mugshot? I hope nobody has ever had the dishonor of getting one.
You need a lens with an equivalent focal length of 85 millimeters or above.
I'm sorry, what is
I'm
85 millimeters?
I'm a camera person. 85 millimeters is focal length, and at that point, your full focusing distance is like, squashed like so far down that everything kind of looks flat. So about 85 millimeters above, that it kind of levels out and it all just kind of looks flat in the photo.
Okay, I'm not a camera person, but I know a thing or two about geometry. So if you take a cell phone camera and you want to do this task, I'm just thinking about how I would do this. Let's say I put a stand and keep my funnel here, and I keep my cell phone at a fixed distance. And then let's say I put a ruler next to the funnel. Okay. If this setup is done, I wouldn't move the setup. I would capture an image to know how much length in the picture corresponds to how much real length. Okay, the reason I brought up the mugshot is they make you stand next to a ruler which will take your height. So they report your height along with your picture. That's the concept I wanted to go for. So don't. This is an experiment you're doing with a funnel, hand soap, and a camera. Don't try to make it too sophisticated. It has to be simple but still scientific. That's all I'm asking for. Okay. No report writing. No giving me 5 pages of AI generated stuff. I want a graph and an Excel sheet that represents the collected data and a video that is the raw data from your experiment that shows you really did the experiment. Raw data, Excel sheet, and a graph that presents your data, and maybe 3 or 4 sentences that you just say what the graph represents. That's it. The work is really the learning, because the report writing, I don't want to make it report heavy. It's more to be about having fun. Other questions? Yes.
So do you want us to do it with a funnel and soap? Or can it be like, is there like a certain thing you want us to do it with?
The funnel is basically adding like a capacity. It holds liquid and it stabilizes the flow rate for you to do a measurement. If you do this with a tube, as soon as you pour it, it's going to flow out. You won't have the time to actually get a steady flow. So that is why I selected a funnel. So you can take a narrower or a wider funnel, but I like the funnel idea because it stabilizes the flow.
Okay.
Yeah. And soap, because soap is going to be very steady to flow. If you do this with water, the flow will be too fast that it's beyond your camera's capability in general. It will give, if you do this with other liquids like honey, molasses, they are too slow probably. They might take forever to flow out. So soap kind of, I tried this at home, it worked, so I'm prescribing that. Other questions? Are we all 18 of us here? 3, 6, 9, 10, 13, 16, 2 missing. Okay, they'll be in the same group. They didn't want that, but that's how it's going to be. So let's divide the class into 9 and 9. And I want you to make the selection. What do you want to do? And depending on that, you pick your side. You want to do the steady experiment or the unsteady experiment? Dr. Hoxton, do you want to add anything to it?
No, it's very, very interesting. The soap is an interesting material.
Yeah. Yeah, the old soap behaves very much non-Newtonian like jelly, gooey, and it goes in blobs.
Yeah.
The new soap is it flows well. Yeah. So the material cost should cost you a funnel. I would suggest getting a funnel that's transparent or translucent so that you can see the liquid level. This one is not particularly great, but this is what my wife would allow me to take here. That's that. You might need to purchase some soap. It might cost you a few bucks. Unfortunately, we didn't. This is not part of the department's plan. It's my plan. So I hope it's okay that if you spend a few bucks on this. It's 3 of you, and let's say $8, it's $3 cheaper than a latte. And all of us have cell phone cameras, so it should be okay. But the real thing is, without a calibration properly done that converts the video frames into a distance, this won't be meaningful. That is, when you report a height in centimeters, you have to exactly tell me how you did the calibration to get that centimeter height or millimeter height. Okay. So in the 3 deliverables I'm talking about are an Excel sheet, a video, an Excel sheet with the data, and the graph. The Excel sheet should contain both the way you calibrate if there is an additional step, as well as the data you collect for your experiment. If you provide all these, I want to keep the grading simple. I don't want to turn this into a lot of partial credits and stuff. If you did a reasonable attempt, I can see that you took a video and the experiment did happen, everything is okay, you get 50%. So 10 out of 20 points. If your calibration and your data collection are reasonable, the data looks correct, but it's not perfect or it's not particularly creative, 15 points, that is 75%. If you present something and we look at it and we go, oh my God, I don't know how he thought of that, and that's awesome, I'll give you 100%. I keep the bar slightly high. Usually 100% is if you did everything that is expected of you. I keep that as beyond expectation. If you do expect it, you are at 75. If you did the bare minimum, you are at 50. If you didn't bother to try this, you'll get a 0. And if you get a 0 out of 20 in this component, that's only 80 out of 100 that you're scoring in the whole course. You are locking yourself at a B or B plus at best. So don't skip this project, which means you are shutting yourself out of A minus or A effectively. Or if you are already staring at a B or a B plus and you skip this project, that can put you in danger territory. So don't do this. Okay? Or don't skip this. Other questions? Yes.
What's the due date?
Good question. So your last lecture is also your exam 3, and then we have a comprehensive final, which I'll keep it very light and have only 3 problems representing 3 parts of the course. So I want to give you 2 weeks from today, so that by exam 3 this is already out of your mind. Because if I keep this around study day, you will be caught between prioritizing this exam and other courses. And the more time I give you, it's not going to happen. I can assure you that. So how about 2 weeks from today? It's a Saturday evening fun-filled exercise. It's like playing beer pong. Have a funnel, drop some soap, take a bunch of videos, do some Excel, you're done. 3 hours stops. And you made some good friends with your teammates. Okay? Yes,
I've got a student, I'm a student, I have a student question.
sure.
Is it okay with you if I use shampoo instead of soap? Because shampoo's got more color in it typically.
Absolutely. In fact, thank you. Shampoo is fine. Any liquid that will get you a decent video is fine. The reason I'm not suggesting water-based liquids is because its viscosity is far lower for you to have control. Soap, shampoo, even if the honey flows well, or you can make sugar syrup, should be okay. It I had another idea where if you want to, let's say you put the soap in here and the liquid flows out, unless the shampoo is colored or has some marker, you can't tell whether the liquid is moving or not just from the video. If the flow is very steady, it's like it's not even moving. So one way to visualize the flow will be to add some particles. So you can bring some fine sand particles, mix it with your soap or shampoo, and use that so that when the particles flow through, you will see the flow being visualized for you. So in your image, if you just track the width of the sand particles, which are basically dots, you can figure out what's the cross section width. So you can use sand or fine sand as a visualization aid. That's one visualization aid. The other thing that I found could work. How many of you know what are chia seeds? Chia seeds, you put it in your morning cereal perhaps. So if you don't, you should. Good for you. Anyway, if you take chia seeds, they are dry little seeds, but if you soak them in water for like 4 hours, they'll become like a gooey colloidal liquid. It's basically like a liquid with its own visualization medium. So if you soak chia seeds in maybe water or maybe in the soap, over time, what will happen is they will start behaving like little particles, but they don't want to touch each other, so they'll spread themselves out naturally. You can use chia seeds as a way to visualize the flow. So here is one way for you to score that top grade, which is to have a way to visualize your flow. It could be colored shampoo. It could be two colored shampoo, like you can mix two different shampoos or two colors of the same shampoo. That is, you can find the same brand in different colors. So you can mix two colors so that you get some visualization. You can use a light. That is, let's say the liquid is flowing out. If you illuminate it from the side or from some other angle, you can get the liquid to glow and use that as a way to track the liquid. So any way that you think of to visualize the flow in your video, that is a ticket for you to do this getting the top score. That is, think a little creative, not just filming a video, which anyone can do. How can I visualize the flow? How can I make it glow? Or how can I make it visible? Okay, think about that. Okay, and everything I said now is being recorded. So if you missed a thing or two, please rewatch this and make sure you capture that. Okay. Again, I know there's a lot of belly aching you guys do about how everything is theoretical and we don't give you a chance to exercise your creative muscles. This is it, giving you a chance to do something. It doesn't have to be perfect. I want to see sincere effort. Okay. Other questions? If not, we can close this and move on to our regular stuff. Thank you. Thank you, Dr. Hoxton. Shall we do the grouping so that today you know at least who your teammates are and you can start planning? Okay, first of all, are we okay with the 2 weeks? Yes, because I'm guaranteeing you, if I give you 4 weeks, you will not get it done and this will mess with your finance. Okay. So 2 weeks from today, and can I have a show of hands, people who want to do the unsteady problem? Okay, I see 4, 5, 3, 4, 5, 7, 8. So obviously you 8 of you would be in one half. And I assume the other people want to do the steady problem, right? Keeping the level steady and measuring what comes out. Okay, so we had 8. Can I have the 8 again? 3. Okay, and we need one more person, right? So from the absentees, I'll pick one and place it in that 9. Okay, I need to do this on the board. Okay, so this is for the unsteady problem. Can I have the names, please? Brian, Emiliano, can I call you Nick?
Elijah.
Rajat.
Eli. Eli.
And yeah, last name? Like 3, 6, 8. Okay, I know who is absent today. Isaac and one Garner. Okay. Okay, I'll put the Garner here. Okay, so we have 3, 6, 9. Any particular groupings that you guys naturally want to do? Okay, who is your third? Nathan. Okay, so this is one group. What's the next group? Come on, who are the next 3 who want to group together? Okay, you want to join their group? Sure. So we have Zain and Elijah. Good. So then the third. Okay, so you guys are doing the unsteady problem. Okay, so for the steady, the remaining half, can I have the names, please? Carson. Let's see if I can remember the names. Sorry,
Trey.
Trey.
Elliot.
Elliot. Okay. Wait.
You know it.
I knew it. I just signed your paperwork the other day. Patrick.
There you go.
George. What's your last name? Christina. Kenzie. Dickerson. 3, 6, 7. Who else am I missing? Yes. Three. Then Isaac. Okay, how do you want to group yourselves?
First 3 together.
Okay. Yes, Christina, Dickerson, and George. Okay, I'll take a picture of this. So this is due by All right. So what's the date? Today's the 2nd. By 16th, that's 2 weeks from today. Okay, due by April 16th, end of day, or even I'll say midnight. I know stuff happens at the 11th hour literally. What is due? What needs to be submitted? Video or videos. If you have multiple videos to share, um, information on calibration. Could be a separate video or an image you took that shows the ruler or some kind of a length standard that is used to understand how much distance is in the frame. Uh, Data collected as an Excel sheet and labeled so that I can understand what the data is. Like I know I'm not emphasizing a report for the reason that if I start asking you to put details, it becomes more work for you. But it can't be just a bunch of numbers that I can't make sense of. Okay, it has to be reasonably labeled for easy grading. And then plots of appropriate quantities. This is a very open-ended exercise. I'm not giving you a lot of the intermediate steps. It will look very confusing. That is normal. I want you to push through that. That's how learning happens. And no matter what happens, don't do the mistake of not having a submission. Because if you don't put anything down, I'll be forced to assign a 0, which can be very damaging for you. Please don't do that. Submit something, submit everything that shows you have done some effort so that I have something to reward for. Okay. Don't make the mistake of leaving it blank. Okay. Did you have a question? No, I thought your hand went. Other questions? Yes. So for unsteady, we want to measure h of t and flow rate and or velocity, flow velocity. For steady, we obviously want to know flow rate and or velocity. It not so much that you have to do everything, but even if you do, let's say only flow rate, I want to make sure your methods are sound. That's all I need to know. Okay, so how I would look at it is if you do think of the steady experiment, your liquid level is always full, and depending on the cross section of the tube and the pressure head available, a certain flow rate is going to get pushed through. You want to quantify that flow rate, how much is it in centimeter cube per minute or per second, and you want to be able to measure it. So how do you measure flow rate? In your class so far, you have learned Q is integral V dot N dA. That's what you have learned. If you know the velocity profile, you can measure flow rate. You can think about the cross section of the liquid that's coming through, and you can try to measure what this cross section is and try to measure what this velocity is. So you can multiply velocity times cross section to get your flow rate. That's one way to think about it. The other reason I'm putting this thing is when you do the experiment, you will find out that nothing is really steady in life. That is, when you set up this experiment, even though you in your calculations, you always assume steady flow and then do a lot of simplifications. Real life, maintaining steady flow is actually so hard that I'm expecting most of you will struggle to maintain a steady flow, no matter how well you replenish the soap or how well your liquid is viscous. It would be very hard to maintain a steady flow. And that's one of the learnings I want you to take away from this. So it might seem like you are not succeeding in getting these numbers measured, but in trying to do that, you would have learned so much. And document every failure, every setback that you get in that trial in a way that if your video, let's say you have a video that shows a failed attempt, submit that. Don't think I'm looking for a very successful experiment. I'm looking to see how hard you tried. If you tried hard enough, I don't care about the outcome so much than making you try. Does that make sense? I want you to try, basically. Not about succeeding. This is the lowest stakes experiment. It's an undergrad course with some bunch of soap. If it gets wasted, nobody cares. So try, make mistakes, and tell me your story. Okay. Not for grading, but optionally, you can record a short video as a team to tell the optional narration. If you want, you can record maybe a 2-minute video to tell me what you did and how you did so that I understand what's going on. If you want, I won't grade it, but at least it'll help me understand. Is this going to put me in teaching award category, or am I going to get buried in my teaching evaluations? Do you like it or you don't like it?
A lot less than I expected.
It's a lot of
It's a lot better than I expected. I was expecting it to be like more
theory.
report.
No report. I hate reports. If you can't tell me in 1 minute, a report is probably useless. You should be able to tell what you did in 1 minute. Sorry, what were you saying?
Having the exam be worth more of our grade.
Yeah, yeah. The exam still is actually quite worth a bit. It's the comprehensive final. I was looking at the syllabus. Is still worth 25%, which I find to be too high because personally, my philosophy is no single exam should be so valuable. If you had a bad day, you have a bad grade. It shouldn't be like that. So if you have other suggestions how we can reduce the weightage for final or get rid of the final, I'm open to it. But this at least is a step forward in that you do something over time and you get points for that. This is 20%. So your 3 midterms are 15% each. This is 20%, final is 25%, and then 10% is for participation scores. One idea I've discussed with some colleagues is to have an oral exam as your comprehensive final, that you and I talk together for 15 to 20 minutes, where I kind of ask a bunch of questions, you answer orally, and we assign a score based on that. Would you guys be open to that? I know some of you are not so interested in talking. No, you prefer the anonymity of paper? See, the option will be challenging because I have to make an exam that is equivalent in written and oral form. That's beyond my brain power. If it's everybody is taking the same exam, it's easy, either written or oral. But you take oral, your friend takes written. I have to make it equivalent for both of you. That's not easy. Anyway, if you have any thoughts, let me know. But as of now, we are doing a comprehensive final. And I want to keep it like very light, 3 problems that capture 3 parts of the course and not make it again a 6 problem or 8 problem, like terrifying final. It should be like for one last time, you study all the topics, you take away what's important. So for the final, I'll give you an abbreviated list of topics. So you don't have to study the entire course. You study maybe like 4 or 5 topics, and we'll test you 3 questions on 5 topics, something like that. All good? No extensions. I don't want to drag this. If your submission is not in on April 16th at midnight, you can assume a 0. Okay. Thank you. Let's see how this goes. Good luck. And come talk to me. It's not like I'll sit back and not offer any help. Come talk to me. Okay. Okay, coming to exam 2, can I get some honest feedback how you guys felt? I thought it was a fairly like plug and chug type of exam, but the feedback I got from talking to people is that they were all not very happy. Yeah.
I think the bigger problem is that even the easy problems were like lengthy in the amount of time that it takes to complete. Like, because for every step that we have to do to derive and figure stuff out, that's more things that we have to write and things we have to read, and that just adds up.
Okay.
So
So timing was challenging.
A
even,
lot of erasing,
Come again?
a lot of erasing,
Lot of erasing.
yeah.
Well, I can't help. That sounds like a matter of practice. Even timing to an extent, the more problems you are doing, the more agile you are. It's just like practicing for physical fitness. So obviously practice more. But I do hear you. That's why I'm making this second option. But I want to still hear about how was the exam.
Thing with me, which someone else told me is like basically the same thing, is I started on question 3 because I was pretty confident on it. And I think I did it pretty efficiently. And by the time that I wasn't even close to the finish. I didn't finish you had to calculate like 3 different, like pi over 100, pi over 200. I looked up and it was already 30 minutes into the exam. And that definitely got me because like, I was thinking this is probably the easiest question for me to get the easy 20 points.
Right.
And I realized that time was kind of catching up to me.
See, that is why I put a table, and the first line in the table is produce me the expression.
Yeah.
And hope is that you will use that expression in the second and third line to substitute and get a number. I thought that will simplify your life, but
It asked for 3 different numbers though. So like,
one of them is just sum of the. It's not a new number. It's like you get A, you get B, you get A plus B. But anyway, I all this points to me again. Maybe we should have done more examples. Maybe you should have done more examples. But we'll work on it. Other feedback on the exam. Yes.
Felt like we didn't have enough time to finish. The exam was just way too long for the
Yeah.
allocated time.
He also said the same thing. So, okay,
I feel like the questions weren't bad,
Yeah, me too.
weren't bad mean too easy or like
like the questions weren't like too difficult to do, they were.
they were consistent with the material, would you say?
Right, yeah.
right,
Okay.
they're just time consuming problems. Like, they're not necessarily that difficult. They fit your schema, some easy ones, some medium ones, and hard one. Like, even the easy ones took like a fifth of the time that you have to do it, and that just doesn't add up with the amount of time that you need to spread it out.
Okay, I hear you. I hear you. So I made up this option wherein to give you a chance to score points. You will take that exam too. Don't discuss with your friends. Don't talk to AIs. Just consult your notes and your textbook or textbooks. Do it like a take-home exam and turn it back in. I'll grade it. Odds are you will score well. You can even score full, which means you get 8 points. And then whatever was your performance on the day was, I'll weightage it for 60%. So if you had a bad day and let's say you're scoring 50% in that test or 10 out of 20 on that test, we'll weightage it for only 60%. So that's like 6 plus the 8 that you will score in the take home part, which will get you to 14 out of 20, which is still a little more respectable. 10 out of 20. Is that okay? Okay, so please do that. For exam 3, I definitely don't have time to do this because by exam 3, our time is done, lectures are all done. So I will try to make an exam that is doable in that time. And on your side, practice, practice, practice. Again, the easy problems may be the ones you can do in like 5 to 10 minutes. Even the average and the hard problem, if you don't practice, you will not be able to do this. And I'm not going to offer a makeup for exam 3, I'm telling you now. Okay, so be aware. Okay. All right, thank you.
So will that be, at the take home video, will that be posted to Canvas or?
I posted the exam 2 questions. Download that, write up your solutions, scan it, upload it to Canvas. I will receive it and score it and keep. I mean, in the Canvas, I still want to keep the official record as only one exam to score. But internally, I'll give 40% weightage to the take home and 60% to the in class. So that when I report Canvas, see, Canvas is a written record. It's going to stay with the university. Your official score will get a little bit upgraded, and your letter grade will eventually reflect that. But I'm giving you a chance to make up through this take home. Okay. And to close out on that, is there anything with my lecture style or instruction style that you want me to change or adjust to help you do better? I know I'm putting this on record. You can criticize me. I won't take offense, but tell me.
I'll say I did like we did the mock exam in class. Like when we did it the week before the exam, I actually really liked that. I want to.
So we'll do another mock exam for exam 3. The either the last lecture before the exam or the lecture before that. Yeah.
And actually starting the question and finishing it with the final answer, even though it might just be algebra by the end of it, just so we can have those
Okay.
clear notes.
I will do that. Moving forward, I'll see until the last number.
At least in my experience, using darker markers is a lot easier to see on the board than like red.
Okay, no red. I'll try to find all black ones or blue.
Black and blue work well, but there have been, some videos where you write in red or green and like the stuff over here basically just becomes invisible.
Oh, I'm so sorry. I will use black and blue. Okay, no more red or green. I'm sorry, I wasn't aware of that. Okay. Right.
I actually really like the teaching style.
Thank you. That one. Okay,
Like,
good. I'll post it on YouTube. Sorry.
I don't know that I've had an engineering teacher that has connected the math to like physical phenomenon so well.
Thank you. I can die a happy man.
I don't think I've ever had a professor ask if this teaching style was good or not. I think you're the first one that's been open to feedback about how we feel about your teaching style. So
I
that's,
mean, we are all learning. So I've been doing this for 10 years. Every time I teach, I'm like, I fucked up so much last time. I should do better.
did you take a break in between? Because I saw your other YouTube videos and you talked
Yes.
a while ago.
I took a sabbatical.
Okay.
I took a sabbatical last semester and I did some exploring of how to use AI in teaching. And basically, I've been giving a lot of unsolicited opinions on AI because I've been researching into how good or bad AI can be on cognitive skills. For you guys, as long as you're in school where the motive is learning, you should stay away from AI because it's like going to the gym and bringing a robot to lift your weights. That makes sense. Your AI is going to do the work for you. Your brain will learn nothing. Brain learns by failing and the experience. So it's like a baby learning to walk. The baby has to fall a few times, right? When you're at your job, you should use AI to get ahead because your competitors, co-workers are using AI. So you have to be competitive. But this place is not for being competitive. It's for making mistakes which have very low consequences. And especially if you get an instructor who is willing to think of those mistakes as part of the deal, your grade should still not suffer too much. So my 2 cents is don't worry too much about grades. In my grad school, I had a GPA of 3.2. I used to go to a class. As soon as I learned something that I need, I'll stop paying attention and walk away and say, I'll take the C. I don't care. I figured out what I needed to do. I don't need the rest of your instruction or your material. And it worked for me. I got work done, I got research published, and so on. So you should know what you want from here and be willing to make mistakes, learn. Don't rely on AI. It's really bad for you. That's all. Long story short. Okay, so we are moving on to a new topic. Okay, it's covered under chapter 7. It's sort of the vaguest topic to think of, but also it's very useful in the big pictures. Um, Let me start with something like this. Think of this funnel experiment. Okay, so you have this funnel experiment. We have our funnel, and you are essentially tracking the height of the liquid. Let's say this is z equal to 0. This is z equal to h, and you want to know what is the height of the liquid as a function of time. This is your unsteady experiment. Let's say unsteady. Okay. You'll do the experiment. You'll get a number, you'll do the measurement. Let's say that's all behind us, and we have a way of knowing the rate at which the height of the liquid falls as a function of time. Let's say that experiment has been done. Today is April 17th, that all that work is done and uploaded, and you scored your 20, you're good. And you have this data. Now I'm asking you the question, what are some of the factors that influence how fast this height will fall? Would it depend on the radius of the cup? Would it depend on the radius of the tube? Would it depend on this length, which in which might have some technical term? Would it depend on this length? Would it depend on the viscosity of this fluid, being, let's say, soap or water or whatever the fluid is? What else can influence this problem? Gravity. Whether you're doing this in Memphis or Norway, where Norway obviously is near the pole, so G value will be different. What else can influence this problem? Turbulence. You could have turbulence depending on the flow. Okay, let's say we talk about the flow profile being laminar or turbulent. What else can influence this problem?
Density matter.
It could, because if weight matters, density would matter. A lighter fluid versus a heavier fluid. So those are all fluid properties. Okay, what other fluid property do you think may be important? If you make the tube narrow enough, that is, this funnel I have here, it has a certain diameter. Okay, it's like about, looks like a centimeter. Okay, I can make the tube not a centimeter, but let's say I get you a tube whose width is only about a millimeter. We can find a tunnel with a funnel with such a narrow tube that its width is only 1 millimeter. So what happens is, when the liquid goes through the 1 millimeter, it will not even flow out, because the surface tension is so dominant in that situation that the liquid will cling on to the tube and never flow out. It will just be stuck there. Okay. So surface tension could play a role, although we didn't talk too much about it. What else can influence this problem? Think. I have a plastic funnel. What if I had a well-polished stainless steel funnel or something that is made of wood, which is very rough? Will that affect?
Like a friction coefficient.
Friction coefficient, or in other words, the surface roughness.
Friction coefficient and that mu. What's the
Mu is viscosity.
Oh, viscosity. Okay.
Mu is viscosity of the liquid, whereas surface roughness is the property of the funnel. What else can influence this problem? Are we done? Is it all? Yeah, this radius.
No, I mean the funnel, because it would create an internal pressure through the,
You mean this height?
yes.
Sure, could affect. So we'll call it H naught something. And think about this edge here. The fluid has to flow through here. Okay, you can make this as a rounded edge. I'm sure some of your CAD course team will come back. You can make this as a rounded edge, or you can make this as a like a straight corner, or you could go a little bit further and turn this in and turn this into a constriction. So the geometrical details here could also influence this problem in a way. Okay? Yes.
The amount of fluid affect the flow rate too, like if you had a huge amount, it would push it down.
Well, that's kind of what I was going with the like height of the funnel basin and the width of it.
I totally agree. How much fluid there is determines how fast it's going to come out. And that's why the flow rate, if you measure the flow rate and or the velocity, the flow rate or velocity will become zero after a while, and it'll not be linear, it will get slower and slower. Okay. So the amount of liquid determines pressure drop, and pressure drop or pressure gradient or pressure, and that drives the flow. So obviously that height of the liquid should matter. The amount of liquid should matter. Is that it? Anything else you can think of? It definitely has something to do because all of these quantities are functions of temperature. So if you did the same experiment here, where the temperature can be maintained at, let's say, 20 degrees Celsius, or in Pakistan, where the temperature can be 45 degrees Celsius in an unregulated, room, the results could look different. So I'm just saying different geography, different temperatures. What else? Yeah. Atmospheric pressure in theory, okay, we will list it because in theory the atmosphere is pushing it down, although the amount of force exerted by gravity is far greater than what the atmosphere can exist, unless your atmosphere is in Jupiter. Okay, so okay, but there is something about the atmosphere which can still influence this experiment. Can you think of? Do you think moisture will influence this experiment? For some fluids, moisture can change their viscosity or flowability, the way they interact with the surface. It really depends on, it's a little bit of a chemistry thing, but for most cases, we'll think moisture doesn't play a direct role. For now, let's leave it out. Is that it? Anything else we can think of? Okay, let's say that's it. Okay, there could be more. There could be another problem in which there may be several lists. The question is, if I ask you a question that has to be answered through this experimental study, which is by doing a series of experiments, can you tell me how flow rate depends on the geometry of this funnel? Like the question, for example, how does flow rate, we'll call it Q, depend on the tube, funnel tube geometry? That's a question to ask. If I ask that question, what are the numbers? So the Q is the flow rate, is the number that we want to understand, and it depends on this diameter or the radius of the tube. So it's obviously a function of radius of the tube. It depends on the length of the tube, or at least we think it does, maybe it doesn't. So at least we should list it because that also describes geometry. It depends on the radius of the bigger cup, the funnel. So we'll say it depends on RC, and it depends on the instantaneous height of the liquid. So we'll call that H of T. Okay. And it also depends on how the edge is. So we'll say it is a rounded edge with a corner RO. call it RO. I asked you a very broad question. How does the flow rate depend on geometry? Whereas geometry in total, it is described by at least 5 numbers. So how will you design your experiment? How will you think of running a number of trials that will give me an answer to the question? I'll give you one pointer. What is the effect of making the cup wider or making RC bigger? What is the effect of that? Will it accelerate the flow or will it make the flow slower? Why? Because there is more material, more of it is bearing down, so more pressure driving the flow. I agree with you. So I'll say increasing RC could or increasing RC increases Q. In our numerical methods language, this is the hypothesis to consider, right? That increasing RC will increase the flow rate, and you can test it by doing the experiment. Now, can you think of another value that also produces the same outcome, but some other variable which produces the same outcome? Like, for example, can you think of increasing
the length from the R naught to the RC?
if you increase L, what will happen is there will be more length to drop pressure. If you increase pressure drop, the flow rate will only go down. If you drop more pressure, the driving flow. So think of the pressure as a driving force. If you spend the driving force in traversing more length, the flow rate will go down.
I was thinking because there'd be more gravity, like there'd be more height in gravity. Because rho GH equals pressure. So
That is true. See, this is the amount of material that is driving the flow. If you increase the amount of material, it will result in more flow going through. But what I'm saying is, in this particular case, increasing length means you have to, it's like having think of this like a pump. This is driving your flow. It's causing the pressure drop. If you have a longer length, you have to put more work, which means for the same amount of work, if you increase length, the flow will actually go down. The flow rate will be low. There is another factor you can think of which will increase Q. Yes.
Biggest factors be how like steep or shallow the walls and funnel work.
We totally missed that. That is, the curvature of this will play a big role. Whether the funnel is this or whether the funnel is this will play a role in accelerating the flow. It's like a nozzle basically, right? So this curvature will play an effect. So which will cause you a larger flow. So we'll say if we think of a conical funnel, if this angle were narrower versus wider, which will cause a larger flow? Narrow, steeper, right? So we'll say this theta, we'll add it to our list. Theta, decreasing theta also increases flow. With me so far? Yeah? Now you are running the experiment, okay? You have two factors which can both lead to the same effect. How do you think of doing the experiment? Should you run the experiment with, let's say, 10 values of RC, okay? 1, 2, 3, 4, up to 10. And then let's say 5 values of theta. If you think about the number of trials you need to do, this is like 10 times 50 trials to 10 times 550 trials to do to map how Q varies with RC and theta. That is, if you want to cover several independent variables, you will have to do more and more trials to analyze or do the experiment. Okay. What we conventionally use not only in fluid mechanics, but also in broadly in all fields of science and engineering, is to understand if all of these quantities are really independent or if they can be expressed as ratios of each other. So instead of trying to think of this RC, okay, I'll redraw this here. Let's say I have a conical funnel. I have RC, I have RT. Do you think there will be a combination of RC and RT for which we can get the same flow rate? In other words, let's say I have this combination RC over RT, where this is 4, this is 1 unit. Okay, 4:1. Okay. The same thing, let's say I make this 6. I make this 6, but instead of keeping this at 1, I also make this wider to be 1.5. So if I do RC over RT, in the second case, that is 6 units divided by 1.5, I get the same ratio. The question is, if you did an experiment with 4 and 1, will it also be the same outcome or the same flow rate as the experiment done with 6 and 1.5? What do you think? We would expect that, because if the physics really dictates that Q depends on RC and RT, and more specifically the Q depends on the ratio of RC over RT, you don't have to do this at every possible value that RT will take or RC will take. You just have to do this at specific ratios which they take together commonly. So this ratio RC over RT is an example of a dimensionless ratio. Example of a dimensionless ratio, okay, which can be varied instead of varying RC or RT separately. What I mean by that is, see, these are all examples to motivate the discussion. We'll do problems separately, but stick with me for a while. Let's say RC values, possible values of RC are from 4 centimeters to 10 centimeters. And possible values of RT are from half a centimeter to 2 centimeters. And then we'll say, for simplicity, Q depends on both of these radii. How many trials would you need to do to cover this range? Let's say you have 6 centimeter span and you split that in 1 centimeter increments. So you get what? 4, 5, 6, 7, 8, 9, 10 centimeters for RC. 6 values. Okay. And the same thing here. Let's say we cover this in 0.25 centimeter increments.
7 values.
Sorry, 7 values. 7. And then RT 0.5, 75, 1, 1.25, 2 centimeters. So that's 1, 2, 3, 4, 5, 6, 7. Again, 7 values. So if I ask you for what is Q of RC over RT, you will have to run combinations. That is, you take 4, you have 7 possible values of RT. You take 5, 7 possible values. So that's 7 times 7, 49 trials to be done. Are you with me so far in the story? We are trying to understand how the flow rate through the funnel depends on the cup radius and tube radius. And to answer that question, you would need to do 49 experiments. Sounds like a lot already, right? But is there a way we can do fewer experiments and still get the same information is the question. So how can we do this instead of doing every possible value? Is there a way for us to do fewer experiments, but obtain the same amount of or same information? So
Try out different ratios.
exactly. So if the analysis of the problem suggests Q depends on RC and RT, that's true, but it depends not on their individual values, but the ratio of their values. Okay, it depends on the ratio of their values, and that ratio, according to this, can vary from what? It can vary from 4/2, that is 2, to 10/0.5 to 20. That is that ratio RC/RT varies between 2 and 20. Right? And how I got the 2 and 20? 2 is basically the lowest value and 20 is basically the highest value of the combinations. This is an important step. Is this 2 and 20 making sense to you? Everyone? Yeah? So the ratio varies from 2 to 20. And I know I don't care about RC or RT separately. I just want to vary the ratio from 2 to 20. And let's say we vary that in steps of 2. So we'll get 2, 4, 6, all the way to 20. That is 10 values, or just 10 trials to be done. Now, obviously, the question is, where did I get the information that Q depends on the ratio and not on the individual numbers? This comes from analysis called, or this comes from analysis which is called scaling analysis. The whole discussion has been to set up scaling analysis, that before you start any problem, I asked you what are all the factors that determine flow rate through the funnel, and we made a big list, and finally we came to this list. Within that, I just collected 2 of those and say the flow rate depends on the ratio, and to vary this ratio, I need to do only 10 trials and not 49. So to summarize, the purpose of scaling analysis is to identify ratios that determine a quantity and use that information for design of experiments. Do you want to write this down? Because when you go home and you think of this topic, what are we doing? We are doing scaling analysis, and the purpose, or what scaling analysis is identifying ratios that determine a quantity like flow rate and use that information for simplifying experiment design. Yes.
Areas, or is it just like you said it?
I just made it up. I could have chosen one, which would still give me, let's say, 20 trials. But what I mean is, whatever resolution I pick here, if I try to obtain similar resolution here, this number will always be larger because you are trying to vary 2 variables. Here you're trying to vary only 1 variable. It's like saying I want to measure at radius of 2 or ratio of 2. Ratio of 2 can be obtained by 4 and 2. It can be 4 and 2. It can also be 8 and it can also be what else will come here? I mean, 2 is a bad example. Let's say I want to target a ratio RC of RT of 5. Can you tell me 2 combinations that will give me 5? 5 and 1. And what else? 10/2. So instead of doing two experiments at 5 and 1 and 10 over 2, I can just do one experiment at 5 and 1. The same flow rate will apply for 10 and 2 because my physics says it would. It's a way to simplify or save effort by doing fewer experiments and using the physics to bridge the remaining or to generate more information. This is the point. The whole point is to be lazy. Don't do two experiments if you can get away with doing only one. Okay. This is one example. The other example I wanted to bring up is, you have heard of Reynolds number, right? At least even if not through this class, you have already heard of it somewhere else. You would we are done here. This is a separate example. What is Reynolds number? Density of the fluid. We'll also see it, okay? But I just want to know what you already know. Times flow velocity multiplied by a length scale divided by viscosity of the fluid. This is Reynolds number. Okay. They invented numbers like these because what they understood is, or what people who worked on this before us understood is, you can take the equations of fluid flow and if you scale it, it only depends on this Reynolds number. That is, the fluid flow or fluid velocity field depends only on this ratio called Reynolds number, especially for laminar flow. It's a fact I'm just telling you, okay? But the more important lesson is, this Reynolds number is the only thing that determines a flow. This is density, okay? Think about this problem. This is density. Let's say for air, you have 1 kg per meter cube approximately. Density. Viscosity of air is around 10 power minus 4 Pascal second. And you have a certain velocity and a certain length scale. And then for water, the density is 1000 kg per meter cube. The viscosity is like 0.1 Pascal second. And a certain velocity and length scale depending on the flow. What do you know from, what can you say from this statement? Water is 1000 times heavier and viscosity is 1000 times more for water than air, right? Let's say we take the same object, like let's say we take a tennis ball, and whatever the radius of the tennis ball is, maybe 2 to, I don't know, maybe 4 inches, whatever the diameter is, we'll keep that constant. If I ask you the question, for what value of velocity will the tennis ball have the same Reynolds number in both air and water? What will you say?
0.
No. Okay. No 0. So there is a factor of 1000 here. There is a factor of 1000 here. Okay. So if you plug it, actually it's not 1000. I think this is not 1000. This is 10,000 times. Yeah, 10,000 times. So if you think about it, if you want the Reynolds number to be same in both cases, the velocity in water has to be 10x higher. Is that correct? Yeah, it has to be 10x higher. That is the same ball traveling in air at a certain speed and the same ball traveling in water at 10x that speed will have the same Reynolds number. And according to equations of fluid flow, or if you want to do an experiment where, let's say, you are trying to measure the drag force on the ball, and all you have is an air tunnel or a wind tunnel and not a water tunnel, you would design an experiment at a certain Reynolds number, but you would still be able to use that for water if you know how to extrapolate or how to scale it. That is the power of these numbers. They allow scaling of different experimental conditions. So all this discussion so far is to get you to pay attention to two words, which is we are going to learn scaling analysis because number one, the number of variables that decide a problem or a quantity are usually too many that if you try doing experimentation with each of them, you will be ending up with an unmanageable number of experiments. So we want to use scaling analysis to reduce the number of experiments. That's the whole point of scaling analysis. Okay. We'll do some examples on at the next lecture. Okay. So before we go, everybody is good with the project. No grievances. 16th April. That's the day. Please have it done. Thank you.
And one that, and. That's one.